Hello children, welcome back to our physics class. I hope you are all doing well and ready to learn something exciting today. Well, in today's class, let us learn something regarding the angle of deviation. And let us also try to find out the deviation produced when a light ray is incident on two plane mirrors inclined at an angle theta. We shall also discuss something regarding the characteristics of plane mirror, types of images as well as types of objects. So, here we begin with. First is all about angle of deviation due to reflection. For this, let us consider the figure as shown. Let us consider a plane mirror. Let us name this as MM1 and let this be a normal drawn to this mirror. Now, let us imagine an incident ray. Okay. So, let this be an incident ray incident at an angle I on this mirror. So, this must be your incident ray. So, we know that whenever a light ray is incident on a surface, a part of it is absorbed by the surface and some part of it may be reflected back into the same medium. So, but as we have considered a plane mirror is generally very highly polished and smooth surface. So, most of the light falling on them must be reflected back into the same medium. So, this is your reflected ray and this must be a reflected angle. So, now our main concept is to find the angle of deviation due to this reflection. Children, suppose if this light ray would not have reflected back, then what would have happened? It would have went to the other surface along this line. Okay. So, this must be the path along which the incident ray should travel. But as the incident ray is reflected back into the same medium, so this is deviated. So, instead of going straight ahead, like instead of making 180 degrees and going straight ahead, what exactly is happening means it is deviated through this angle. So, instead of going straight ahead, it is after deviating through this angle, it is returning back into the same medium. So, this angle itself is called as angle of deviation, indicated with the letter D or delta, indicated with the D or delta. So, delta is also the symbol for angle of deviation. So, now our main concept is to find out the value of D. So, here we go with. So, what must we actually, we know that from the laws of reflection, As we know that from the laws of reflection, which we have studied, angle I must be equals to angle R. Okay, so this angle I must be equals to angle R. If you observe this carefully, earlier I told that this angle must be 180 degrees. Okay, if you want to find out only D, D must be equals to, from figure, we observe that this D or this angle I plus this angle R plus this angle D, okay, this portion of angle, this portion of angle and this complete portion of angle all together will give you 180 degrees. Say yes or no. Okay. So, all the three, summation of all the three angles together will be giving you as 180 degrees. That is, I plus R plus D must be equals to 180 degrees. But as we know that angle I is equals to angle R. So, wherever we find R, let us replace the same with I. Okay. So, replacing R with I, we have I plus D must be equals to 180 degrees, or 2I plus D is equals to 180 degrees. Hence, D must be equals to 180 minus 2I. So, this is the value of angle of deviation. Hence, angle of deviation is found to be 180 minus 2 times of the angle of incidence. Instead of this, we also know that I can be replaced with R. So, or we can even write the value of D as 180 minus 2R. But generally, we will be writing, considering this as the general formula, that is D is equals to 180 minus 2I. Suppose in some numericals, if the value of I is not given, and as we know that I is equals to R, I can be replaced with R and you can use even this formula. But let us not consider this as a formula itself, just to make you understand, I have given that. I hope the concept of angle of deviation due to reflection is clear, children. Okay, if this is clear, let us try to understand the extended topic of this regarding the deviation. Children, suppose that you were given two plane mirrors inclined at some angle theta as shown in figure. Let us see. Let us try to plot the picture. So, we were given two plane mirrors inclined at some angle. Let us indicate that angle be some theta. These two mirrors are kept at an angle theta between them. And let a normal N1 be drawn to the first mirror and another normal N2 be drawn to the second mirror. So, normal means perpendicular drawn to this mirror. So, whenever a light ray is incident on the first mirror, so I name this as first mirror and consider this as second mirror. Let us suppose that a light ray is incident on the first mirror, suppose in this direction. Okay. So let this be a light ray incident on this mirror. Then no doubt, as it is falling on the plane mirror, the light ray is reflected back into the same medium. Well, so we consider that this light ray is incident on this mirror, making an angle alpha, So if angle of incidence is alpha, then angle of reflection must also be equals to alpha. Is it clear? Then if you come across with the second mirror, the second ray, this is your incident ray for the first mirror and this is your reflected ray for the first mirror. Whereas if you consider for the second mirror, this line will be the incident ray for the second mirror, whereas this will be the reflected ray for the second mirror. Okay. So this is your angle of incidence. It might be incident at some other angle, say beta. Let us suppose this angle as beta. So alpha and alpha is your incident ray, alpha is your reflected ray. In this second mirror, beta is your incident ray and beta will be your reflected ray. If you observe this picture carefully, as this is the normal drawn to the surface and this is the mirror, angle between the normal and the mirror is no doubt it is 90 degrees. If the angle between the normal and the plane mirror is 90 degrees and this portion is alpha, then the remaining angle must be equals to 90 minus alpha. Yes or no, children? Among this, okay, if you consider this right angle triangle, okay, if this portion is alpha, then this portion must be equals to 90 minus alpha. Similarly, if you consider this particular right angle triangle, this is the normal drawn and this is the surface and angle must be equals to 90 degrees. If the total angle is 90 degrees and this portion is beta, the remaining would be again 90 minus beta. So this portion must be equals to 90 minus beta. If you observe this triangle carefully, we know all the values. Here it is 90 minus alpha, here it is theta and the other it is 90 minus beta. So as we know that the sum of the angles in a triangle must be equals to 180 degrees. That means here, what is the sum of the angles? One is 90 minus alpha, the other is 90 minus beta and one more is theta. The sum of all the three angles must be equals to 180 degrees. So we have 90 and 90, you have 180 degrees and this is minus alpha minus beta plus theta equals to 180 degrees. Here also 180, here also 180 gets cancelled. So if you carry this minus alpha and minus beta to the other side, keeping the theta here itself, minus alpha moving to the other side will become plus alpha and minus beta moving to the other side will become plus beta. Hence, the relation between the angle of inclination, angle between the two mirrors and the angle of incidence on the first mirror as well as the second mirror, that is alpha and beta, is given by theta equals to alpha plus beta. Okay, I hope the concept is clear, children. So now based on that, let us try to find out the deviation produced by, so here two reflections we can observe, deviations produced by the number of reflections when incident on a plane mirrors inclined at some angle. So how to find out the deviations? Here we know that if this is the incident ray, it would have travelled in this particular direction, but it is deviated through some angle and it is coming back in this direction. So the deviation produced by first mirror will be something. Similarly, the deviation produced on the second mirror due to reflection is something else. So let us try to calculate the same. So the total deviation produced due to the two different mirrors, it is two different reflections. First reflection on first mirror, second reflection on second mirror, okay, is deviation produced by the first mirror, let me represent with some letter delta 1, and deviation produced by the second mirror, that must be delta 2. What is delta 1? Where delta 1, children, only formula is sufficient for you, but to make you understand clearly, I am explaining how the reflections and refractions taking place, okay. So, just final formula to remember is more than enough, no need of derivation and all, okay, but look into me. Coming to the delta 1. So, what is delta 1? As we know that any deviation is equals to, instead of going straight ahead, it is deviated through some angle, say angle of incidence. This is 180 minus 2 times of the angle of incidence. So, first deviation is produced here. That portion is nothing but 180 minus 2 times of, what is the angle of incidence on the first mirror? That is alpha. Similarly, delta 2 can be found out as 180 minus, what is the angle of incidence on the second mirror? Beta. So, 2 times of beta. So, based on this above formula, I am directly using that. Deviation is equals to 180 minus 2 times of the incident angle. So, first mirror incident angle is alpha, second mirror incident angle is beta. So, the total deviation produced is equals to delta 1 plus delta 2, that is equals to 180 degrees minus 2 alpha plus 180 degrees minus 2 beta. Or D can be written as 180 plus 180, I can together write it as 360 degrees minus, this is 2 alpha, and here we have minus 2 beta, minus 2 alpha and minus 2 beta. So, finally, D can be written as 360 degrees minus 2 taken common, you are left with alpha plus beta. But in the